Hi all, welcome to yet another video in the series of Infrastructure as a Code with Dell's storage platforms. And this time around, we will be seeing Terraform with Dell's PowerScale. Dell's PowerScale is a very noteworthy and comprehensive platform that actually encompasses a broad array of use cases ranging from traditional file-based workloads to advanced analytics, AI, ML, the latest and greatest hype around Gen AI and whatnot, right? So it's a very potent and powerful platform and has been adopted in our customer community hugely, actually. Now, this video is basically a step ahead in terms of how you can actually leverage something like Terraform, which is again a very powerful resource with PowerScale here, actually, right? So allow me to share my screen and I will walk you through the construct of what's going to happen here, what we are going to deploy, and the observations actually. So I'm going to share my screen here, and you can see that right here on my screen, you can see the web console of Dell's PowerScale. And note that Dell's PowerScale is powered by, at its core, it's OneFS, which is again a very potent and powerful framework, which actually which is the core engine behind PowerScale. Now, as of now, we don't have anything configured. It's a blank system with defaults. Let's just look at the file system. Okay, file system. There will be a default in terms of IFS directory, and then the subdirectories under that, data and home. In terms of the file exports or the NFS exports, there are none as of now. So you can see that as well. There are all the default users basically in terms of, root, nobody and whatnot. Now, what we're going to do is we're going to use Terraform to provision a user group, then a file system, and then a NFS export for that. And we're going to validate that through a NFS client running on a Ubuntu machine. Okay, so it's that simple. Now, one interesting thing to observe is that, a OneFS, or let's say in this case, PowerScale, is, like I said, a multi-protocol access system. So you can see the range of use cases that it supports, including S3 and Hadoop. So yeah, very diverse, very powerful, very potent, enough said there. Now let's go to the, so I'm on a Ubuntu machine here. Okay, this has Terraform implemented on it or, deployed on it. And if I look at what's there in my directory, so you can see that there is a main.tf and a variables.tf. Let's see what's there in main.tf. So we start by declaring the provider here, which is again, like I said, PowerScale, and you can see the source here, right? And the version for that source is 1.1.0. I'm going to supply, obviously, it's there in the variables, but these 4 variables to the provider, which is my username to access the PowerScale, the password, the endpoint, which is basically the same URL endpoint suffixed by 8080 port number. And since this is a self-hosted, it has a self-signed certificate. So I'm just going to skip the SSL validation there. Now, like I said, we will start configuring a user, which in this case, I'm just going to say, okay, let the user be Ubuntu. And the group it belongs to is also going to be Ubuntu. Okay, so you could actually, configure different combinations there, but for this demo, I'm just going to keep it simple as Ubuntu. Now, next, we're going to actually create a file system. The resource is called as PowerScale file system. And for that, you saw that there is a /ifs. So under that, I'm going to create a directory called as data1. Data already exists, so I'm going to actually create a new one called as data1, and then align that with the group and the owner being the user that we create here, actually, which is Ubuntu. So you can see the reference here, basically PowerScale user group, example user group.gid, right, which is this one here. Yeah, example user group. And then the owner for that particular directory is going to be the user that we create here. So PowerScale user example dot user dot example user dot UID, which is here. Okay. So since we are not declaring the UID and the GID for the user and the group, PowerScale will automatically generate that for us. So we're just gonna extract that once the resource is created from these, parameters. Now you can see that once we have, we've actually attributed the directory path, the name, the group, and the owner. We can create different combinations in terms of access control. For now, I'm just going to let it be public read write and recursive being true, which means that if I had subdirectories under data 1, it would automatically generate those directories as it executes the resource creation. Okay. So now, up until this point, the resource for the file system has been created. The next thing obviously would be to create an NFS export for this particular file system. So we are going to create a resource called as PowerScale NFS export. And then the paths are going to be referencing this example file system, which is being created here, right? So it will automatically derive the full path, which would be /ifs/data1. I could do different amount of or different types of, again, access control from an IP basis. I'm just going to keep it open, but I could use specific IP addresses or host names, to kind of restrict the access to the NFS export. Once this is done, I'm going to do the mapping in terms of, the user and group. So you can see that map all enabled true, primary group being, the same group that we've created here, which is Ubuntu, and the user being, Ubuntu as well. Okay. Now that's about it. I mean, and you can definitely generate different kind of outputs. What I'm showing you is a very simple, way to kind of, execute or observe how Terraform operates with PowerScale provider. But if you go to the official website in terms of our Terraform documentation, you will see a broad range of parameters and attributes that you can, or use cases that you can actually thwart out using, Terraform. Plus, we've also got the ability to import, attributes out of an existing PowerScale system, so that you can leverage those attributes and configure, sequential calls into different resources actually, right? So, I mean, lot of things can be done there. For now, I've shown you the GUI. I've shown you or walked you through a very basic, Terraform script here. So let's go ahead and just execute that. Okay, Terraform init, Terraform plan, Terraform apply. Auto approve. Okay. Note that I'm not putting any smart quotas and anything on the file system. You can, like I said, you can actually do a lot of restricted calling, so that it kind of aligns to your use case specifically. Now, once we do this, obviously you can see that the initialization has started, and it took 10 seconds to do whatever it had to do in that. And the whole execution is complete here, right? This is what you're seeing is you can see that the apply has been completed, 4 resources added, 1 user, 1 group, 1 file system, and the last one being the NFS export. And the output is the entire block for the NFS export configuration. Now I can use this output in many different ways actually, but for now, let's go ahead and validate this from a GUI perspective, right? Let's go back to the GUI here, and I will just refresh this. So you can see that there is a NFS export created, which was our last step in the execution, and it is exposing the path called as /ifs/data1, which is what we had created through a file system resource, right? So let's look at the file system resource. Okay, before we do that, we can also observe. You can see here is, you can see this, that the mapping of the root user is also done to the user UID and the GID, which is around Ubuntu and Ubuntu. Again, you are seeing a number here, but we will see and observe it in the GUI when the user and the group is observed for Ubuntu, right? So note this, it has automatically done the primary mapping, actually, user being 2007 as UID and group being 2006 as UID, okay? So, GID, sorry. Now, we will just cancel this. So the NFS export is there. We will see the file system explorer, and you can see that this is the new directory. It has been created here /ifs and then /data1. Okay, right now it's empty. You can see that, and you can see this is the path, empty. Yeah, nothing else there to see for now. Let's go and see the user and the group that has been created. Okay, so we go to membership and roles, say file system. Let's just hunt for Ubuntu. Let's see if there's Ubuntu created. Yeah, okay. So you can see that there is a user Ubuntu that has been created. Okay, and like I said, you can see the UID is automatically created for it, 2007, and we could see it in the NFS export that the export was mapped to this particular UID. Now we will also similarly look at the group that has been created here. So let's go to groups. Okay, you can see the Ubuntu group has been created. Let's look at the GID for this, and 2006. Yeah, and this is the user, which is a part of the Ubuntu group actually. So all this is done basically, right? Now it's the time to kind of validate whatever has been implemented is configured correctly, so that I can use a NFS client to mount this particular export, and then start doing whatever I need to do from an application context perspective, right? Okay, so I'm going to log in. Yeah, so what I was saying is we will log in into one of the client machines. Let me do it from here itself. So SSH, let's say Ubuntu into 10.204.111.33, if I'm not mistaken. That's my machine. Okay, let's see if I remember the password. Okay, yeah, okay. So it's a Ubuntu machine. It has NFS utilities configured. So for now, let's say I will just remove, I had created the directory test here. I'm just going to clear that. Okay, so we will start by creating, let's say, a directory called as test. Okay, and then we are going to mount this particular directory test through this NFS share. So you can see that I'm using the sudo command to mount NFS in verbose, and then this is the IP address that we can see of our PowerScale. You can validate this here, 100, and then yeah, the path that we are going to mount is ifs/data1, which is the path that we map to our export, and the directory that we will be mounting is test. Okay, so let me supply password, and you can see that the mounting is successful. How do we verify that? So let's just say df-h. You can see that my directory test is now mounted on this particular NFS export, right? Let's just try creating a couple of files. test1.txt and test2.txt and test3.txt. Okay, so far so good. Let's verify this in the GUI. I will go back to the GUI. You could see that earlier this was an empty file system, and that data one did not have any content in that. And yeah, that's about it. I mean, you can see we have all 3 files created. Now this is a typical, NFS configuration. I mean, you know what else to do with it, right? And if you've already worked with PowerScale, again, the power of this particular, or the comprehension that you can actually render there. Yeah, so I think, as you can see that, the files are created, and that's about it. So I hope you enjoyed, a short demonstration of how do we use Terraform with PowerScale /OneFS. Again, note that, while you are looking at an on-premises deployment or a co-located deployment of PowerScale, the same system is available for one to consume in the cloud. For example, Apex File Services in AWS. So that's one of the great examples where you can use, same OneFS in the public cloud and, derive use cases from SageMaker to whatnot, actually. Okay. Thank you.